Right, so today we've got another Cybernet 134 set, and this time it's a rather immaculate looking Harrier CBX. What does it say? For servicing, can I purchase a new mic from you? Yes. Right. Well, in that case, we'll set it up with the new mic, but just initially, just for those initial tests, we'll use our standard mic. The ones we're selling at the moment now have to be the coffin mics. I do prefer this style, but they don't seem to be available with a screened lead on them. Right, how does that go in? So the spigot is downwards. Right. So we were on Cybernet before, so we can use the same power connector, and I'll plug the extension speaker and thus the test equipment into the extension speaker socket. And while we're plugging things in the back, we'll plug the public address speaker into the public address socket. So that's a good start. So apart from doing 19 carol services, I've now done 4 of those. I've had an extra one sprung on me. Would I do the school one at whichever school? 9:30 tomorrow. So I've had to phone the lady I'd help with the shopping and tell her I'll be an hour late. I don't know. Fancy booking an organist with 2 days to go. Right. So we'll switch the power supply on. I've got no reason not to switch it on at 13.8 volts. There we go. And power it up. Start at channel 20. Make sure everything's where we need it to be. So there we go with that. I'll tell you what, we'll check the PA right now. I'll turn it, you'll be on the mic gain. Testing 1 2, testing 1 2. Ah, PA's not working. Oh. Oh dear. I think the switch has been repurposed for something dodgy in the past. Right, so we'll go over to the, we'll put picture in picture on. And, oops, we're on the wrong one, that's that one, that's it. Right, let's see what the transmit power is. 4.4 watts. Let's write some of these things down. Harrier CBX, no PA, TX 4.4 watts, that needs to come down. Let's get deviation. Wallow. Deviation equals 3. That needs to come down. Frequency. Put you on that camera. 2779081, that is enough to be saying it's off frequency. 2779081. And let's see how the receiver's performing. So I need to match the signal generator to the frequency it's actually on, so that it's a fair test. So 27779. So it's 79081. Right. So we are hearing it all right. Let's go over to the Synad meter. I'm just going to change scales. Very good, actually. And over to the attenuator so you can see what I'm talking about. So for the 12 decibel Synad on the screen, we're on the 1 scale with between the 2 and the 3, so it's actually 2.95. So 2.95 microvolts for 12 dB Synode, which is about where we were with the last one we did. Right, we'll whip the set apart. Turn the volume down for people who don't like to listen to 1 kilohertz tone. You know, when you've spent 40 years in an electronics workshop, your brain notches out the tone and you just don't even hear it. I'm being attacked by the bench cookie. So I'm just going to have to print some music off for tomorrow. Hopefully it's all scanned into my computer and I won't have to start scanning it. So I'll just get through the transmit. Now if this has been hacked about for the public address wiring, then this will halt CB repairs for a very long time. I've only got 40 minutes twice a week to spend on CB radios. So put that on the piece of polystyrene. Undo the speaker, which is the 3-inch one on these sets, not the more generous 3.5s you get on the Biontone 5-star. It reeks of fags. We'll just tip over the pot of screws and then put them back in the thing. So public address switch is the third one along, and it's only got 2 wires going to it. It needs about 5. So I would think that hacked about wire is something to do with it. But it's a lot of work because it means we've got to open up another set, and we've got a hacked about wire there. You see, it's just all not all soldered together, and it needs some sleeving on there. So they put some tape on there, but you know, fair enough. So it's been doing something silly in the past. Perhaps it was a Roger Silly. Right, so we'll get on to the tuning. Right, see what we can remember, because you know what my memory's like. So we need to be on channel 40. Turn the volume down, we don't need to listen to that. We need to be on the earth, which is that strap across there, seeing as it's a floating chassis on these sets. And we need to be checking the VCO voltage just there, end of resistor 4. And in receive it's supposed to be 4 volts, which it isn't. I'm going to put the soldering iron on. I'm going to do this the wrong way around because the soldering iron wasn't on. It'll save time, hopefully, if I do the other one first. So we'll look at the transmit one, which should be 4 volts. It's 3.2, 3.12. That's fine. Now we'll look at the receive. This one's far enough out for it to have been deleting channels. That is out. It is important to set the right way around, and so that was a total waste of time doing transmit first when it tells you to do receive first. You can see why now. So 4 on receive, 4 on transmit, 4 on receive, 4 on transmit. Let's go to channel 1. It's 2.12 on receive. Should be between, is it 1.8 and 2.3 or something like that, and it's similar on transmit, so that's fine. So that did need resetting, so I'm glad I saw that. Right, so we're done with that. So transmit. So as I said earlier, it was doing 4.4 watts, which is thrashing it, apart from the legality side, which of course I'm, as you know, everything I do needs to be spot on. Which camera are we on? That one. So we're now at 4.6 watts. Oh, we're on channel 1, aren't we? Let's try again. 4.5 watts on channel 20. So we need to peak this on channel 20. I want to be quite rapid because, and on key in between, because I don't want to overload the PA, the power amplifier stage. So these 3 now need to be for maximum. And that was maximum. And that was maximum. And that was maximum, which is not how they're set. You know, never let this ever happen because it's just thrashing the set. So we need to be setting, the manual says L4 needs to be clockwise for 4.4 watts. Well, it's 4.5 watts at the moment, so we just need to move it clockwise. It just starts to move, which is now 4.4. And then we need to be setting the L9, I think it is, the green one. It says in the manual 3.8 watts, but we're allowed 4 watts, and so we'll have our money's worth. So there we go, that's now 4 watts. So we'll just check channel 40, and it's about 4.05 watts, and channel 1 is also 4.05 watts. So I've actually got that spot on the money. From cold it's 4.05, so we can let that go at that. So that's absolutely fine. Don't think you're gonna. This does not affect range. The difference between 4 and 4.4 watts is, you know, matter of feet. It just doesn't make any difference. Don't think it's a percentage. You know, if you got 30 miles on, let's say you got 30 miles on 4 watts, that on 5 watts you're going to get 35 or 4. You're not. It makes so little difference. It's just ridiculous. We've done these demonstrations on amateur radio at different power levels just to show how little difference it makes. So your next power level to double the range would be 64 watts. So, and you're certainly not going to do that on CB legally, and there you go. Right, so that's done that. Let's make sure that the power meter is also reading 4 watts. Remember, when this is on an aerial, it'll read whatever it wants. It doesn't mean a thing. So actually it's bang on the 4 watts, but I'll just adjust it. There we go. Well, have I got a Midland lid just arrived on my person. So we need to set this so that this one's in the central position and this one's the deviation. So let's get the oscillator out. First of all, we'll just do the Warlow test. Testing Warlow is 3, it's too high. Let's try that. Warlow. That's too low now. How can that be? Warlow. I don't get this. I've turned it down a smidging and now it's miles. Warlow. Still too low. I just wonder if the preset's dirty and it was just on a funny bit. Wallow. Let's just try that. Wallow. Still too quiet. Wallow. 1 2. Wallow. 1 2. Don't get this today. Testing 1 2. Wallow. That's it. Good grief, that took some adjusting. Let's just make sure it sounds how we'd expect on the monitor set. Testing 1 2. Testing 1 2. Yeah, it does. Right, check low power. There's another switch that gets repurposed into something silly. So low power should be 400 milliwatts, in other words 0.4 watts, and on this set it's doing 2.6 watts. And now it's doing 400 milliwatts. It's back to high power. Back to the high range on the test set, and it's doing the 4.05 watts that we seem to have set it to. So that's where we are with the transmit. Just look at the time. Just see whether we can... Oh, we'll do the frequency. There we go, that's now spot on frequency. So now we'll set the signal generator to where it should be now, which is 27.79125. Okay, that'll do me. Now we'll go to the Synad meter. No, we won't. We'll go to the oscilloscope, which I'll actually switch on. With an S9 signal, that's 100 microvolts in the UK for a CB radio. On the signal generator, we want a meaningful waveform on there, and just check that the detector coil, the demodulator, just there, is maximum. It was spot on. So now with the Synad meter, see whether we can get an improvement on receive, even though it's very, very good. Microscopic one there. Got the extra receive circuit in this model. Just put a bigger signal on for these. Or slightly out. The one under the wiring harness. Spot on. That's it. Just go back to the first two. There we go. Right, get a new reading. 12 dB Synad. Go over to the attenuator. I'll use the other scale like we did the first time. We've actually got 0.25 of a microvolt. fact, I could say 0.245, but we'll say 0.25. Just turn the volume down. Well, I didn't expect to get an improvement. That's very, very good. Anyone seen where the pen's gone? Right, so we're now 4 watts. 2.2 average to 2.5 absolute peak. That's the peak before. So that's done. 27,79125, that's done. And 2.5 microvolts for 12 dB cyanide. So that just leaves the squelch to check. So I'm going to turn the squelch to full on the radio, and then we're going to set the attenuator on the signal generator to 100 microvolts slowly. So that's 1 microvolt, 3 microvolt, 10 microvolts. We want the squelch to open at 100. 30 microvolt, 100 doesn't open. So 300 it does open. So it's just slightly out of adjustment. Just need to adjust the preset there. These are silver, so I'll show you that by just cleaning it up. Just tarnishes. That's it. That's opening to 100 microvolts. So now we'll do a squelch sensitivity test. So we'll turn the squelch down, turn the attenuator on the signal generator to 0.3 of a microvolt, and then switch it to standby. Set the squelch on the radio to threshold, so the background noise has just disappeared. Switch the signal generator back on, and then we'll see at what point it comes in. And the answer is 0.52 of a microvolt. It disappears off about 0.48. So there you go. Squelch is nice and sensitive. So that'll be good for scratchy corner. So we just need the S meter to read something near. So it should be 100 microvolts for the 12 dB. Sorry, it should be 100 microvolts to show S9. And it's a bit generous. So we'll just turn that down a bit. That's the preset there. There we go. So as far as the radios goes, that's now set up. So this is where this session will end. Another session I'll now have to look into why what wiring goes where on that switch which has been messed up. So hopefully we've got another Harrier CBX in stock here. I know we do have one, but some of this stuff is in storage. So I'll see you on the next session. So my good friend David Quotagius, who often puts a comment in on this, just take picture in picture off, has come back to me. I said, have you got a Harrier CBX? And he has. So they're the connections. So with the radio in, he's got it that way on. Yep. So CB is the top of the set. So it's yellow, red and white. So as you can see, we've got a red. We have got a white. So is it still connected to where it should be? So it goes to post 35. Well, that's post 35. Oh, that's great. So that's still there. So red, he says, looks like it goes to the volume switch. So it's going to be here, isn't it? So it's just simply, I'm going to cut this because it's so nasty. Yeah, that goes to the power switch. So this red one, which is connected to what? Ah. So this is a red one, which also goes to the power switch. So I'll snip that off really close. So that's got rid of another nightmare which didn't need to be there. I think they've had a Roger Horror on there. Well, it'll weigh a bit less when he gets it back. So if I snip these two, so I mean, I guessed that this was something. I thought there'd be about 5 wires. There often are on CBPA, so I'm not sure how it's done, and I'm not going to bother looking at the Harrier circuit to find out either. Harrier circuit? We don't have a Harrier circuit. I meant to say Rotel 240 circuit. We'll tin these. It'll be easier with them out this side than the other. So if it's red in the middle, we'll do that one next. That's there. And that just leaves us with the yellow. But that has saved so much bother with having David send me this information. He's also sent me a photo which I would have printed out if the printer was behaving itself. Good. Huh, see whether it works. Power back on. Right, well, the CB mode is still working. So switch it to PA. Testing 1, 2. And volume control on the mic. Good. Well, that's that solved. Now, I've put that piece of tape back over there and it's disappeared off. So I'm hoping I've got some sleeving on this bench. No, I'm going to have to get some sleeving off Mr. Chippy. So we'll have to pause the video. Right, so I've just been making a mic up for this. So, what have we got here? Pin 1 is transmitted audio. It's a white wire on these mics. That's the screened one. Pin 2 is the screen, which we'll put some sleeving on. Pin 3 is the receive, the black wire on these mics. And pin 4 is the red transmit one. So let's hope I haven't lost all the screws. The worst thing is when you've forgotten to put the boot on and you've got to unsolder it all again. Yeah, I think we've all done that. I'll try and get away with just taking one screw out. You always need to put some sleeving on the wire because the clamp isn't sufficient. In other words, the wire's a little bit thinner by about 0.5 millimetre than is ideal. And then you end up with the sheath coming out and the wires grinning, which is the last thing you want. We'll get that tied down, or screwed down even. And then there's the teeny weeny screw. Which Knights actually sell as a replacement for 25 pence. I kind of find it best to load it onto the screwdriver like that. There we go. Right, I'll put the set back together. It really does make this whole making switches do something else. I really find it frustrating. Oh, B/goat. Is that Billy Goat? That's what it says there. Yeah, I do find it frustrating. I don't know whether people do this with cars as well. You know, I don't use the heated rear window very much. We'll repurpose it to the flying button or whatever people do to motor cars. Right, so that's that bit. It's a funny case, you know, when you compare it with all the other cases. We don't need to keep the PA speaker plugged in anymore. We've done that. We don't need to keep the instrument speaker plugged in anymore. Done with that. Put the lid on it. That's twice I've caught this pot of screws. So I'll put them in loosely and then we'll tighten them up. So you're not, you know, if you start again, if you try and tighten them up individually, there is a bit of tolerance and things just might not fit properly. So it's always best to just enter them, put them in loosely and finish them off. So Mr. Chippy says, is there a scratchy corner test to do? So there will be. I said yes. Just got a mic to make. Did you see I put some did I discuss that I put some sleeving on that wire, which had a bit of bareness to it, which went to the mic connector. That's not going in properly. Yeah, this is what I'm talking about. That is definitely either the wrong screw, even though it came out of this set, or just hasn't lined up properly. Let's try a different screw in that hole. Yeah, that's alright. And now we'll go back to the screw I was struggling with. It's not the best of screws. I'll just use a bigger screwdriver so we don't make it any worse. Right, we'll take it off the test equipment and put it on the roof aerial, which I've said a million times before is an Antron 99 type. It's the one without the ground plane kit, which is an option, and it's mounted on this single story building just above the gutter level, so it's not that high, and it's deliberately done like that. Oh yeah, I haven't got the mic plugged in, have I? I wonder why it's quiet. So we'll just see what it sounds like on this mic. Testing 1 2, testing 1 2 3. Before I take this off the bench tomorrow, I'm going to check the deviation again, just in case there's a discrepancy between this and our test mic, which we set it up on. So we've got the aerial plugged in, we're on its internal speaker, so make sure these are where they should be. Have the tone there. One and a Roger. No.
Yeah, 1 9 Roger, you got this one, come on. Hey, estimate, I can't hear you when that...
Breaker saying this one, yeah, thanks for that. I think we've got a Roger. Do you think we've got a Roger? Do you copy this one's a strange thing to say? Is that their call sign? I don't understand that. So he's got he's got gout. Is that what he said?
Not sure about me.
So high, medium and low on the tone. Right, we'll put... Oh, he has got gout. We'll take it to channel 31 onto Mega Chippy channel, ready for the on the air test. So there we have it, Harrier CBX. Receives very good on that. And really, it was all the transmit was a bit skew, if it was slightly off frequency, and then of course no public address facility working. So that's it. Thanks for watching. Another 1981 Cybernet 134 set back, ready to go to the customer. Thanks for watching.